So today we are going to discuss a project, online shoppers intention. So let's go with it. And so this is the overview of our presentation. Firstly, we are going to discuss about the objective, means what is our final goal for the data we are given, and we will see data pre-processing, and the EDA part means exploratory data analysis. What are the steps? And we will see some different models, and then we validate those models with the help of confusion matrix and the different validation score. We will see just like precision, recall, and accuracy, and at the end we will just compare all those different models, which model we should adopt, and what are the benefits of which module. And at the end we will see conclusions. We will draw some conclusion on the basis of given data. So let's proceed.
Sure.
So this is our objective. So we are given a data. This is the online shoppers activity data. When a user visit a website and he just go away from the website, we are just collected the data of that session only. So we have around 12,000 data. We will see, and our final goal is if user is visiting a website, whether he is generating revenue, means whether he is doing shopping from the website or not. That is our final goal. So now we start with pre-processing. So firstly, let's understand our data. So data is given in CSV file, and in our data, we have 18 features. 18 features means we have 18 columns, and obviously one is our target column. And we have in our data, we have 12,330 rows. Each row represent a individual session by a user. And we can see we have different type of features, numerical variable and categorical variable. And we have 10 numerical variable, and in categorical variable we have 8. Out of these 8, a weekend and revenue is our target variable, and these two, weekend and revenue, are in boolean form, means they have the numbers in, sorry, numbers, no, they have a true false type of data only.
Yeah.
So if let's understand each data. So firstly administrative. So these are the number of pages user visited, and administrative duration means how many times and how many seconds user spend on that kind of pages, login, sign up type pages. And then informational means these are the pages on website that gives the information about the company profile, all these things. And the informational duration means how much time user spend on this type of pages. And the product related means these are the product related pages, means if user is searching any product, then sometimes he find some review, he go deep into the product detail, he compare the products, all these things. So these are product related pages. And how many times user visited, data is in product related duration. And the bounce rate is a, means we can say that it's a metric that measure the average rate of means in terms of percentage is visited, the percentage of the visitors who left our website just by seeing the one page only, means they didn't go to the next page, they just open a page and they just navigate away from the website. And the exit rate is also percentage of the visitors who navigate away from the website from a specific page. So, and now we have page value. Page value is the means average page value of a page that generated the revenue before the that generated the revenue. So this is the average value. And then we have special day. Special day means if let's say there is some Mother's Day, Valentine Day, all these things. So this shows the nearer of the special day from the current day on which user is visiting the website. So this data is in form of probability. So in categorical variable, we have months. We have only 10 months of data. So we have only 10 type of months. And operating system, a browser, region, tariff type means how user came to know about the website. And visitor type means is it a old visitor or new visitor, like that. And weekend, if it's a weekend, then it's a true, otherwise it's false. And revenue, if user generated revenue, then it will be true, otherwise it's a false. Let's go ahead. So this is our 5 numbers only. So here we can see what is the minimum value in a particular column and the maximum value and the value observation count. So here we can see that there is no missing value in our data, but in the whatever this is the rectangle box, we can see that here minimum value is 0 for informational and informational duration column, and also in page value, and this is special page, sorry, special day column. So we can see minimum value is 0, and first quartile value is also 0, and second quartile value is also 0 here and here also, and here we can see third quartile value is also 0. It means our most of the data is in form of outliers only, because if minimum value is 0 and first and third quartile is 0, then our IQR value will be 0, means all the data is greater than our upper value. So here we won't apply any outlier treatment, because if we will apply any outlier treatment or we will apply any capping method, then the remaining data will be converted into 0 also. So for these 4 columns, we won't apply any outlier treatment. So let's go. So this is the pre-processing part. We are doing outlier treatment. So here we are finding the first quartile, then third quartile, and we are finding the IQR value. Then we are deciding our upper limit, lower limit, and then we are just applying capping method and flooring method for all the required columns only. So we have just written the column, means we have written the column index, 0th column, first, fourth, 5, 6, and 7th column only. So now we have converted our categorical data into dummy variables, because if we want if we will go with a label encoding, then there might be an issue, because higher number may get higher significance. So we are going with label encoding. Sorry, we are going with dummy variables. So here we can see how many unique numbers we are having. Yeah, we can see in the administrative page we are only have 27 unique numbers. And if we talk about categorical column, we have 8 types of operating system. In browser, we have 13 types of browser. In region, there are 9 types of regions. Traffic type is 20 types. There are 3 types of visitors. And as we discussed, we have only 10 months of data. And weekend and revenue have only 2 types of data, true and false. Now scaling, because firstly we are going to apply logistic regression, so scaling is also required. So before scaling, we are seeing any multicollinearity is there or not. So we created a heat map, and heat map is created. Then we find that there are some higher correlation factor is there between some columns. So we just removed those columns. We removed administrative duration, product related duration, and bounce rate. And then we just we segregate the dependent and independent variable. As revenue was our dependent variable, so we have put in y variable, and in x we have our all the independent variables. And then we apply scaling, we applied normalization. We didn't apply standardization because our data is not normally distributed, so we are going with min-max scaler. So this, we apply trend test split. Here we are considering 0.3 test size, means 30% of data for the testing purpose. And yeah, then we apply our logistic regression. In logistic regression, we can see that we are finding the training accuracy of 87% and test accuracy of 87.78%. Precision is quite good, but recall is very low. And here we need to focus on recall. So we are not going with this model. So we are going with another model, because here recall is very low. We will understand what are these terms. So we can see here, with the help of this confusion matrix, we will validate our model also. So we can see here we have true negative 3078. True negative means actual value is 0. 0 is our means negative. 0 is representative negative, and 1 is representing as a positive term. So true negative. So true negative means our actual value was negative, means 0, and our model also predicted as a 0, means negative. So it's a true negative thing. And if we talk about false negative, means actually it was positive, means true, but our model predicted as false. So it's a false negative. And if we talk about true positive, means it was a actually it was positive and model also predicted as positive also. And false positive means actually this value was negative, but model predicted as positive. So this is our confusion matrix. Now accuracy. What is the accuracy? Accuracy is nothing, just a ratio of the total correctly predicted output divided by the total output we are getting. So here we can see true negative means correctly predicted true value, and true positive, sorry, true negative means correctly predicted negative value, means it was negative and model also predicted as negative. And true positive means it was actually true and model also predicted as true. So this is the sum of this one, 3078 and 169. So we are getting 3247 and divide by these all summation of these four numbers. So we are getting accuracy of 87.78%. And the precision. Precision is the ratio of true positive upon predicted positive. These are representing predicted positive numbers. So we are getting 76.81%. And the recall is the true positive means the number which was actually a positive and model also predicted positive divided by actual positive. So this is the our main concern, recall. Our recall should be decent value. So here we are getting 29. Why recall is our major concern? Because we see false negative. And what does it mean by false negative? As we discussed, the actual value was true. True means our user is generating a revenue, but model is uh, predicting predicting that it's not generating revenue. It means a user generate revenue means it's our good customer, but our model is saying that no, it's not purchasing anything. So it means we can't focus on that user, then we may lose that user only. So this is not the good thing. We need to focus a customer which is purchasing, then we want that he should purchase more and more in the future also. We can't lose that customer. So recall is our main concern. Okay, so let's go ahead. Yeah. Then our next model is KNN. In KNN, we applied some pre-processing steps just like outlier statement, multi-collinearity, we check with the help of heat map and label encoding and scaling. If we see in label encoding, why we applied only label encoding? As we know, KNN is the distance-based algorithm, and in distance-based algorithm, we prefer dummy variables. But when we are not getting good accuracy with dummy variables, then we can go with label encoding, and that's what we are doing here. Okay, so now after applying the KNN, we are getting result. Train accuracy is around 89, that is quite good, and test accuracy is also good. Precision is 70%. Precision is decreased a little bit if we compare with logistic regression. And recall is also increased a little bit, but we can say it's not up to the mark. Even it's not even a 50% also. So now we are going with another model. But in KNN, here we can see there is one parameter n neighbors. So it means this parameter is a hyperparameter. So we need to tune it. And why we took this as 11? Actually, we take just randomly take and then we decide. And how we decide, let's see. Yes. So this is our graph. If we see our graph, we can see these are the values of k and these are the accuracy of our model for different k values. So we can see we select the value of k that is giving the good accuracy. If we here see that here we can see that k equals to 27 is giving the good accuracy, but we are selecting as 11. I will tell why. Actually, firstly, we will select only odd values. So there will be no tie condition in the model. But we selected 11. Let me show you why we selected. So here we can see, and this is the graph. 1 minute. Yes. So here is the this is the same graph, but we also drawn gen and recall also. This is the accuracy graph we can see. So here 27 is giving our highest accuracy. But what is happening at k equal 27? Our this you can see recall. Green line is recall. Our recall is very low, and we can't compromise with recall. But at k equals to 11, we are getting a quite good recall, and accuracy is not there is no much difference. good precision also. So that's why we took k equal 11. So let's come to the, yeah. So we are going with k equal 11 only. And now our next model is decision tree. So in decision tree, we applied some, we checked the multicollinearity with the help of heat map. Then we applied label encoding. The same issue is also there. We are getting good accuracy, and in decision tree, we don't get any much difference if we are going with dummy variables or label encoding, these things. And we didn't apply any outlier treatment and no scaling, because in decision tree there is not much impact of outliers and in scaling also. So we can see this is our model. There are, we took some parameters, maximum depth of the tree. Actually, what happened if we take the very much depth of the tree, then our model become more complex, and it creates the problem of overfitting. So we take a decent value. So we will decide using the hyperparameter tuning. Either we can go with the grid search CV method, or we can do it manually also. Here we are doing it manually. So, and criterion means when we split a node, there are some criteria. So there are two criteria, Gini entropy. So we will decide which criteria we will apply. So we just selected maximum depth as 5 and criteria entropy. But how we decided, we will see. So we are getting the accuracy. Train accuracy is 90%, test accuracy is 89%, and that is very good. And precision is 68, but recall is above 50%. We are getting around 59% recall. That is quite good. So let's see how we tuned our model. So we can see this is the table from means how we tuned. We can see this is the depth of the tree, maximum depth, and we can see this is the training accuracy for entropy, where we are taking the criteria as entropy, and this is the test accuracy. Yeah, this is the test accuracy. And this is train accuracy when we are using the criteria as Gini. And this is our test accuracy when we are taking the criteria as Gini. So we can see that for test accuracy, we have the highest accuracy here for k equal 5, and the criteria is entropy. So we took here maximum depth 5 and criterion equals to entropy. Okay, we can understand in a good manner also with the help of graph. Yes, we can see here for these two lines, means orange and blue, these are representing train accuracy. So train accuracy is always increasing when we are increasing the tree depth. So we are not concerned about train accuracy. We are concerned about test accuracy. So we can see green line is representing test accuracy for entropy, and this red line is representing test accuracy for Gini. So we can see for entropy is line always above the Gini, and the maximum peak we are getting at k equals to 5. Sorry, its tree depth is 5. So we just, that's why we selected the tree depth is 5 here, and the entropy criterion equals to entropy. So that's why we selected these hyperparameters. So now let's go with different model. So what happened in our data, our data in target variable, if we see, we had 12,000 total data, total observation, but around 10,000 they were false was there, and around 2,000 true was there. So this is highly imbalanced data. So we can also try with balancing the data if we are not getting good accuracy. In decision tree, sorry, here in decision tree, we were getting a recall of 59% and precision of 68 and overall accuracy 89%. So let's try with the balanced data if we are getting good accuracy or not. So we tried balancing the data. Here we applied oversampling approach. We are not going with the downsampling, because if we go with downsampling, our data will be reduced. So there might be a problem of underfitting problem. We need more data to get trained our model. So we are going with oversampling, and we can also go with test, but we are not going because in smooth original data, in smooth new data is created for the minority of class, but these are data are not original data. They just modified data. But here duplicates are created for the minority class. So we are going with oversampling only. So in oversampling, we can see that we are getting train accuracy is 88, test accuracy is decreased if we compare with decision tree without balancing. But precision is also decreased, that is around 50%, but recall is increased very well. It's around 81%, and that's our major concern. So we have seen four models. Now we can compare these four models on the basis of validation score. So if we talk about the accuracy of each model, we draw some different graphs, and these are the for training data, these are for testing data. So we can see we are getting a good test accuracy for with the decision tree. So if we are talking about accuracy only, we can go with decision tree. But accuracy is not the only thing when we are solving a problem based on classification. So here is the different comparison with different validation score. We are having our four models: logistic regression, KNN, decision tree, and decision tree with balanced data set. So here we can see accuracy is around 87. We are concerned about test accuracy. So test accuracy here 87, here 88, 89, 84. Test accuracy is very low here, but we are getting a recall of 81%. So here we will go with decision tree with balanced data set, because here we are getting a very good recall. Okay. So, and if we talk about precision we are getting a low in logistic regression, highest precision, but recall is very low, so we can't go with logistic regression at all. So here we have done the comparison, but now with in a given data we drawn some conclusions also. Yeah, in conclusions, if we see this graph, this is the graph of weekend versus revenue count. So we can see uh, true means there is a weekend, and false means there is no weekend. And revenue count means how many users or in how many sessions revenue is generated. So we can see when there is a weekend, revenue number of revenue is less when there is no weekend. But we can see that in the weekend we have only 2 days, but a non-weekend we have 5 days. So more time is there. So that's why we have more number of stations. We can see around 8,000. If we talk about total, 8,000 plus around 1,500 means 9,500 total. 500 total sessions were there if it's not a weekend. But here we can see one thing also. Total 9,500 users visited the website, and only 1,500 generated the revenue when it was not weekend. So it's around 12-13%. And here if we see around 23 or 2,400 user, sorry, it's not 24, it's around 3,500 user visited the website, and around yes 500 generated the revenue. So it's around 19 18 90 19%. So percentage conversion rate here, conversion rate is good, but here conversion rate is low. So this is the concern for the marketing team, means something is wrong or need to reevaluate their strategy. Means when there is no weekend, conversion rate is very low. So this is the point. And if we talk about next conclusion, then we draw the graph month-wise revenue count. So we can see we had 8 months, and this is our revenue count. So we see that in the month of March, May, October, November, and December, we are getting more revenue. And in February month, there is no revenue. And in June, July, there is less revenue. So our marketing team should concern about it, should make a strategy, means why we are getting a less revenue in those months. And if we are getting good revenue in November and conversion rate is also very good, so it's a good. So means something we are doing in November that things are missing in these months. It's a concern for us for these remaining months. And reason wise, if we talk about revenue, then we can see in this region 1, 2, 3, 4, we are getting good revenue. We are generating good revenue. But for these regions, we are generating very less revenue. And if we talk about visitor type, yes. So here we can see returning visitors. Returning visitors, these are the visitors around it's 1,500 visitors who are generating the revenue. Returning visitors means they are our old visitors. They earlier also they make purchase thing. and new visitor means they are first time they are coming to the website. So if we see conversion rate, we can see for the new visitor conversion rate is 24%, and for the new returning visitors conversion rate is around 14%. So there is a much difference of 10%. This is not a good thing. Means why our returning visitors are having less conversion rate. This is the concern, because it means we are losing our old customers. So it's not a good thing, and we are getting good new visitors. It means there are some offers for the new visitors, so that's why they are purchasing things in much percentage, in high percentage, but returning visitors are not interested in purchasing. So return conversion rate is very low. So this is the concern. We should take care of it. And this is the browser wise revenue. We see there are mm, browser number 1 and 2. There are much revenue with these browsers only. It might be a famous browser, that's why most of the people use. That might be the thing. And yes, and this is our visitor type versus product related duration. So this is means how much time user spend on the product related pages. So here we can see new visitors are spending less time. We can see here, but returning visitors are spending much time. We can see graph is going till here. So what does it mean? It means new visitors are and I also shown in the previous graph. In this graph, it means new visitors are having more conversion rate. Conversion rate is high, but they are spending less time on product related pages. It means they are just means there might be we can say there is definitely some offers for the new visitors. So they just want to avail the offers. They are not searching the product, they are not comparing, they are not getting into the description of the products. So that's why they are staying on the list for the less time on the product related pages. But returning visitors are spending time means they are comparing the products, they are reading the descriptions, they are reading the reviews. So they are spending more time, but conversion rate is less. It means there is something strategical error, strategical mistake we are doing with these visitors. So here is the area of improvement for our team, research team, and yes, and this is our special day probability. We can see when special day probability is 0, most of the revenue is coming at that time only. So we should also think about it, because it's a good thing when probability is 0, but what about these areas? This is not the good thing. So this is also a concern for us. Yeah, thank you.